Welcome to the Pure Storage Non-Disruptive Everything video series. Pure Storage FlashArray is commonly deployed for mission-critical mixed workload consolidation where resiliency is a core requirement. The FlashArray not only matches the resiliency of legacy Tier 1 arrays, but it raises the bar with non-disruptive operations with 100% performance. Software upgrades, capacity expansion, and controller upgrades, including next-generation controller upgrades, are all performed non-disruptively and without requiring maintenance windows, data migration, or downtime. In this three-part video series, we will step through the different non-disruptive operations that can be performed with Pure Storage FlashArray, including the following. 1. Non-disruptive software upgrades of the Purity operating environment, which powers the FlashArray. 2. Non-disruptive generational hardware upgrade from the FA-420 series to the new FlashArray M. 3. Non-disruptive intra-generation controller upgrade from a FlashArray M20 to the FlashArray M50. And 4. Non-disruptive capacity expansion. This video series provides an in-depth view of the entire non-disruptive upgrade process, including the CLI operations that are performed and the addition and removal of the physical hardware that takes place. All the while, an active mixed workload is running on the array to simulate real-world environment. This mixed workload includes one Microsoft Exchange JetStress 2013 virtual machine simulating 5,000 user mailboxes at 1 IOPS per mailbox. One Microsoft SQL Server 2014 OLTP virtual machine simulating a brokerage firm conducting trades. Two Microsoft SQL Server 2014 DSS virtual machines simulating continuous report generation from 2 data warehouses. One Oracle 11G virtual machine simulating a DSS workload, and all virtual machines were hosted on an 8-node ESX cluster. Let's start things with the software upgrade. The FlashArray web management interface provides an active view of the current performance of workloads running on the array. As previously mentioned, the array is running 5 different workloads. Notice we are running at sub-millisecond latency of 0.49 milliseconds, generating over 57,000 IOPS and bandwidth of more than 1.5 gigabits per second. This next visualization is of 2 Microsoft SQL Server 2014 instances. SQL 1 is the OLTP instance generating 1.3 gigabits per second, and SQL 2 driving a DSS workload of greater than 200 megabytes per second. To perform a software upgrade of the Purity operating environment, the Pure Storage support team logs into the FlashArray with the root account. Customers do not have to perform software upgrades themselves. Instead, they enjoy fully managed upgrade experience with vast majority of the software upgrades completed remotely via our secure remote assist connectivity. Once logged into the FlashArray, we run the PureDB list mode CLI command to check if we are connected to the primary or secondary controller. We can see that CSG NDU CT1 is the primary controller. Our best practice for software upgrades is to start from the secondary controller. Connecting to the CSG NDU CT0 controller using SSH peer and running the PureDB list mode command shows that CT0 is the secondary controller. Prior to starting the upgrade, we staged the package to be installed. For this specific upgrade, we are going from Purity 4.5.5 to Purity 4.5.7. The software upgrade process is the same regardless of the Purity versions. To start the installation, we run pure install using the ppkg file. Once the new package has been installed, the installation complete message is displayed in the instructions that at the next reboot, this new version of Purity will be loaded. We issue the pureboot reboot secondary command to reboot the CT0 controller. A notification that the controller is going down for the reboot is displayed. Since we connected to the CT0 controller through the peer link, we are brought back to the CT1 primary controller. As the CT0 controller reboots, we switch over to the FlashArray web management interface to show that no performance issues have been encountered. The controller shows red to indicate it is offline currently. To determine when the CT0 controller is ready, we issue the watch command using PureArray list controller to view CT0 and CT1 in the system and their status. At this time, we can see CT1 primary is an FA-420 model running Purity 4.5.5. After a short time period, we can see the CT0 controller is now ready and is running the new version of Purity 4.5.7. We can escape out of our watch state and switch over to the web management interface to show both controllers are online and there have been no effect to the application workloads. Now we can move on to upgrading the primary controller. Now we run the same pure install command as we did on CT0. The same process takes place and the new Purity package is unpacked and verified for installation. Once the installation completes, a reboot of CT1 is required for both controllers to be at the same Purity 4.5.7 version. The pure boot reboot primary command is issued and the CT1 controller reboots to load the Purity 4.5.7 on restart. Quickly switching over to view the web management interface, we can see the controller has rebooted and marked red to show that it is offline, and we are still providing all the performance of the workloads with no issue. Logging into the controller and using the watch command, we can see that both CT0 and CT1 are on the same version. Also notice that during the software upgrade of CT1, that CT0 took over as primary. We switch back to the web management interface and see that the FlashArray is performing without interruption. Finally, we check the SQL Server instances and see that there has been no effect to the database I/O. That's it. The software upgrade is complete. All it took was 5 steps in a few minutes. In the next video, we will show the non-disruptive upgrade from an FA-420 to a FlashArray M20. This is super exciting as it's enabling Pure Storage customers to avoid the legacy technology refresh cycle every 3 to 5 years, and instead non-disruptively upgrade their arrays to the latest and greatest technology without data migration, without downtime, and without having to rebuy the hardware and software. We call that our evergreen storage.